With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is a gram of KH oxalate, that is potassium hydrogen oxalate, are required to reduce 100 ml of 0.02 molar KMnO4 in acidic medium, and B gram of potassium hydrogen oxalate neutralizes 100 ml of 0.05 molar calcium hydroxide. Then we have to find out the relation between the A and B. So let's start solving this question. For solving this question, first of all, we are considering the first reaction, that is when KH potassium hydrogen oxalate when reacts with the KMnO4. Okay. During this reaction, what happens? The KMnO4 is acting as an oxidizing agent and it is getting converted to Mn2+. From here, KMnO4, as we can see in the case of KMnO4, the Mn has oxidation state, that is +7, and it is getting converted to +2 oxidation state during the reaction. So we can say there is overall change of +5 units. Okay. Now take the other component of the reaction, that is potassium hydrogen oxalate. Considering this, what will happen? The carbon will get converted to carbon dioxide. Okay, from here to here. Here the oxidation state of carbon can be calculated like this: +1, then +1, then +2x minus 4 into 2, that is 8. Okay, so that will give us 2 plus 2x is equal to 8, or you can write 2 8 is equal to 6 here, or you can say x is equal to 3. So we took out the oxidation state of carbon here, that is 3 plus 3, and here the oxidation state of carbon is +4. Okay, so there is overall change of +1 unit, but as 2 carbon atoms are there, so we can say total change in the oxidation state can be calculated like this: total change in oxidation state, it would be 2 into +1, because 2 carbon atoms are here, so we can say 2. And for KMnO4 it was 5. For KMnO4 this value is 5, and for potassium hydrogen oxalate this value is 2. Now as we have calculated the n factor, so we can use here the formula, that is equivalence of KMnO4 would be equal to equivalence of potassium hydrogen oxalate. For calculating this, we can consider that KMnO4 is given to us, which is having 5 change in 5 units is the change in the oxidation state, as you can see here. So 5 into molarity of the KMnO4 is given in our question, that is molarity is 0.02 here given. As we have to put here in the equivalence of KMnO4, we have to keep here the number of moles of KMnO4. Okay, and we are keeping this molarity. Okay, so how we can change it into the number of moles? Number of moles can be calculated from molarity like this: molarity multiplied by volume, and if the volume is in ml, then what we can do? We have to divide it by 1000. Okay, so this is the formula. By using it, we are given here with the 100 ml of solution, and so to convert it into liter, we are dividing it by 1000. Now come to the KH potassium hydrogen oxalate. For this we have calculated the n factor, that is 2 here. So n is 2 into A is the variable which is given to the what? Number of moles of potassium hydrogen oxalate. So we can calculate the n from here. A from here. So we can calculate the A value. A value can be taken out like this. A would come out to be, that is 0.005 moles. Okay, so this would be the value. That is how much? 0.005. That is, this much moles of potassium hydrogen oxalate is required to neutralize 0.02 molar KMnO4 solution. Okay, now let's see the second reaction. That is when potassium hydrogen oxalate is reacting with the calcium hydroxide. Okay, now we can see here, in this case the N factor would be here 1 only, and in the calcium hydroxide the N factor would be here 2. Because how the reaction would occur? Let's see. Potassium hydrogen oxalate can be written like this, and when it combines with the calcium hydroxide, then the reaction would occur like this. K, potassium won't be reacting and only H would be removing out from here, and the bonding would occur like this. Okay, so this would be the product. So N is 2 here and N is 1 for potassium hydrogen oxalate. Now we can write here the equivalence of KHC2O4 is equal to equivalence of calcium hydroxide. Now as we are given here with the N is equal to 2 for calcium hydroxide, okay, and it is having the molarity, that is 0.05, and the volume is same, that is 100 divided by 1000, because we have to keep it in liter. Okay, now come to the KH oxalate, potassium hydrogen oxalate side. What is happening here? Here N value is 1 here in this reaction, and B is the number of moles. So B can be calculated for this reaction. Okay, so B would come out to be, that is 0.010. Okay, this would be the number of moles of potassium hydrogen oxalate which is required by the second reaction. Okay, so this we can number as second, and we had just calculated for first reaction. What was A? A was this. Now we can take out the ratio of A by B. That would come out to be 0.005 divided by 0.010. So that would give us the value, that is B is equal to 2A. That is our correct ratio. Okay, so let's choose from the options given here in the question. B is equal to 2A is the correct one. So second option is correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.